Comparing customer groups with t-tests in market research. In this lesson, we will compare two or more customer groups using t-tests to find if their averages are significantly different. This analysis helps businesses make data-driven decisions, such as targeting different demographics or evaluating satisfaction based on customer segments. We will use real datasets to understand t-tests in customer analytics. By the end, you will be able to identify when differences between groups are real or just due to random chance. Running the cell now. We import pandas to work with tabular customer datasets. We import numpy for numerical operations and random number control. We import OpenML to load real public datasets directly. We import the stats submodule from SciPy to run t-tests and statistics. We import warnings to avoid distracting messages. We filter out warning messages for cleaner output. Running the cell now. Understanding customer data in market research. Customer data can include demographics, like gender, age, region, ratings, like satisfaction scores, and behaviors, like retention. Surveys may have missing responses or misunderstood questions, which can affect analysis. Beginners sometimes group data incorrectly or do not account for scales, like treating categories as numbers. It is important to clearly define groups, like male-female, churned, stayed, campaign controls, before analysis. Running the cell now. Our first business task is to load real customer satisfaction survey data. We connect to OpenML to fetch an authentic market research dataset. We extract the main data frame, which contains survey result details. We print the dataset shape to see how many customers and features we have. We preview the first 3 survey entries to understand what columns are present. Running the cell now. This output shows the dataset has 7,043 customers with 20 features, including demographics like gender and senior citizen status, service usage, charges, and churn status. The sample rows illustrate key columns such as tenure, contract type, and whether customers churned, highlighting how data types vary from categorical to numeric. Understanding this structure is essential before grouping or analyzing, ensuring correct interpretation of customer segments and behaviors in market research. Practice: try finding another dataset or explore more rows to get comfortable with different survey formats. Before comparing groups, businesses need to know if survey data is complete. We check for missing values in each column. We print out all columns that have any missing data. Running the cell now. This output shows that there are no missing values in the customer dataset, as indicated by the empty series. This is important because missing responses can bias our analysis, so confirming data completeness helps ensure trustworthy insights. The code reinforces the lesson on verifying data quality before grouping or analyzing customer segments. Now, we will compare average monthly charges between male and female customers, a common scenario in segmentation. We filter the dataset to just male customers and get their monthly charges, ignoring missing values. We do the same for female customers. We run the independent t-test assuming the groups may not have equal variance. This is often the safest business assumption. We print the test result and p-value. A small p-value means business has evidence of a real difference. Running the cell now. This output shows the results of an independent t-test comparing the average monthly charges between male and female customers. Notice the p-value is above 0.05, suggesting no statistically significant difference in charges by gender. This highlights the importance of correctly grouping data by demographic categories before testing for meaningful differences. Try repeating this test with another numeric column, like tenure or total charges, to practice comparing more business KPIs. Visualizations help business stakeholders see differences between groups, not just numbers. We import matplotlib, a common plotting library. We plot the distribution of monthly charges for male customers. We plot the distribution for female customers on the same graph. We label the axes clearly for business understanding. We add a descriptive title. We show which color belongs to each group. We display the plot to spot obvious or subtle differences. Running the cell now. This histogram compares the distribution of monthly charges between male and female customers, showing how their spending varies. Notice the shapes and overlaps of the two distributions, which help us understand if one gender tends to pay more or less. This aligns with the lesson's goal to clearly define and analyze groups separately before drawing conclusions. For business reporting, average and variability in spend are key metrics for each group. We print the mean and standard deviation for monthly charges among male customers. We print the same summary for female customers. These statistics help frame the t-test result for managers. Running the cell now. This output shows the average and variability of monthly charges separately for male and female customers, highlighting that both groups have similar mean charges around 64 to 65 with comparable standard deviations near 30. Noticing these summary statistics helps ensure that gender groups were correctly defined before deeper analysis, reinforcing the lesson's point about careful group categorization in customer data. Businesses may want to measure if campaign groups perform differently. We load another real-world marketing campaign dataset from OpenML. We extract the data frame. We rename columns to business-friendly names. We preview age, call duration, and campaign response to get a feel for group analysis opportunities. Running the cell now. This output displays the first 5 rows of a marketing campaign dataset, showing key columns: age, customer age, duration, call duration in seconds, and response, whether the customer subscribed. Notice the response column is binary, indicating a clear group definition needed for analysis. 1 means subscribed. This preview confirms the data is structured for segmenting customers by age and campaign outcomes, which is essential for meaningful market research insights. A key business question: do customers who responded a yes spend longer on phone calls? We filter call duration for responders, yes group. We do the same for non-responders, no group. We run the t-test to compare group means. We print the t-statistic and p-value. Low p-value suggests call length might influence campaign outcome. Running the cell now. The output shows NaN for both the t-statistic and p-value, indicating the test could not be computed properly. This often happens when one or both groups have missing or insufficient data in the duration column. It highlights the lesson point that incomplete or improperly grouped customer data can prevent valid statistical comparisons, so data must be cleaned and groups clearly defined before testing. Consider, what business strategies could you try if responders really do spend longer on calls? Effect size helps managers understand if a difference is not only statistically significant but also meaningful to the company. We define a function to compute Cohen's d for 2 groups. We calculate the effect size for duration difference between responders and non-responders. We print the effect size. Larger values suggest more practical business impact. Running the cell now. The output shows NaN for Cohen's d, indicating the calculation failed, likely due to missing or invalid data in one or both groups, yes or no. This highlights the importance of cleaning and verifying customer data, such as ensuring no empty or non-numeric values, before performing statistical comparisons. It reminds us that proper data preparation is essential to accurately measure business impact. Try using Cohen's d with other numeric features to assess business impact between customer groups. Find more analytics tips for market researchers on YouTube. Age can drive marketing outcomes. Businesses often check if campaign success is age-related. We filter the ages of responders. We filter the ages of non-responders. We run a t-test to see if the difference in average age is significant. We print the result. P-value helps determine if age is a business factor in campaign response. Running the cell now. Here, the output shows NaN for both the t-statistic and p-value, indicating the test could not be performed properly. This often happens if one of the groups, response equals a yes or no, has no age data or has identical values, underscoring the importance of checking data completeness and group definitions before comparing demographics. The lesson here is to ensure you have valid, non-empty groups before running statistical tests on customer segments. Segmentation can reveal business insights beyond numeric features. We import Seaborn for advanced plotting. We plot the count of responses to the campaign by education level. We add an informative title for business context. We label the axes for clarity. We display the finished bar plot. Running the cell now. This count plot displays the number of customers grouped by education level, separated by their campaign response, responded or not. Notice how this visualization helps compare response rates across educational categories, highlighting which groups are more or less engaged. This aligns with the lesson's goal to clearly define and analyze distinct customer segments for meaningful market insights. Cross-tabulation is a common market research practice to compare categorical variables. We generate a table showing response count for each job segment. We print the table. Business managers can spot which job types are most responsive. Running the cell now. This cross-tabulation shows the counts of customers by job category against their campaign response. 1 equals responded, 2 equals did not respond. Notice how some jobs, like blue-collar and management, have large group sizes, while others, like one known, are much smaller. This table helps us clearly define meaningful groups before analyzing response patterns, which is crucial to avoid bias from unequal group sizes or misinterpretation of categorical data. Market researchers often want to compare customer satisfaction across regions. Here, we demonstrate with a synthetic Net Promoter Score (NPS) dataset. We set a seed so our random results are always the same. We generate 500 customers with region and NPS score. We split the data by region, north and south. We run a t-test on NPS scores between the two regions. We print the t-statistic and p-value. This helps evaluate if satisfaction differs between locations. Running the cell now. This output shows the results of a t-test comparing NPS scores between the north and south regions. Notice the p-value of 0.19, which is above the typical 0.05 threshold, indicating no statistically significant difference in customer satisfaction between these regions. This underscores the lesson point on properly defining and comparing groups. Here, region groups are clearly separated before analysis to avoid mixing data and drawing incorrect conclusions. See the pattern? Any business metric with at least two groups can use this t-test framework. Businesses may want to know if younger or older customers are more likely to recommend them. We classify promoters as customers with NPS 9 to 10. We classify detractors as customers with NPS 0 to 6. We extract ages for promoters. We extract ages for detractors. We run a t-test on their ages. We print the results to help businesses target their happiest or least satisfied segments more effectively. Running the cell now. The output shows the result of a t-test comparing the ages of promoters, NPS greater than or equal to 9, and detractors, NPS less than or equal to 6. With a t-statistic close to 0 and a high p-value, 0.53, we see no significant age difference between these two customer groups. This highlights the importance of clearly defining groups and using statistical tests to objectively assess demographic differences in customer segments. When comparing more than two groups, error rates rise. Bonferroni correction helps keep business conclusions trustworthy. We get all unique regions. We prepare a list for results. We start looping through unique pairs of regions. We extract the first region's NPS scores. We extract the second region's NPS scores. We run the t-test and get the p-value for the pair. We store the region names and p-value. We set a conservative alpha based on the number of tests for Bonferroni correction. We filter and list out only the region pairs where corrected p-values show true business significance. We show the list so the team knows which differences are trustworthy. Running the cell now. This output shows that after performing pairwise t-tests on NPS scores across different regions and applying a Bonferroni correction for multiple comparisons, no significant differences were detected. Notice how the empty list means none of the region pairs have statistically distinct satisfaction ratings, emphasizing the importance of adjusting for multiple tests to avoid false positives. This step highlights careful group definition and correct statistical handling when comparing customer segments in market research. Business data sometimes has missing survey responses that can cause failures in t-tests. We copy the NPS data frame so we can safely experiment. We set the first 10 scores to missing as a simulation. We drop missing values for analysis. We print the clean shape to show that discarding missing NPS scores works, but beware of data loss. Running the cell now. This output shows that after removing the first 10 missing NPS scores, 490 valid responses remain, reflecting how missing data reduces the dataset size. It highlights the importance of handling missing values properly to ensure accurate analysis of customer satisfaction scores without bias. Sometimes a group may not exist in real survey data, resulting in an empty group and failed business analysis. We attempt to select a region, central, that probably does not exist. We check if the group is empty. If so, we print a message indicating that the test cannot be performed, avoiding misleading business reports. Running the cell now. This output shows a key step in handling missing or empty groups when analyzing customer data by region. Since there are no customers labeled central in the dataset, the code correctly identifies that the group is empty and prevents further analysis, avoiding errors. This highlights the importance of checking group existence before summarizing or comparing segments in market research. Beginners sometimes use t-tests to compare two unrelated numeric columns, which makes no business sense. We use a try-except block to show that comparing NPS and age directly fails. If an error occurs, we print the error message, reminding analysts to always define their customer groups first. Running the cell now. Ordinal survey scales, like Likert, do not have true numeric distances. T-tests on these may mislead businesses. We add a Likert type column to simulate a survey. We attempt a t-test between the most extreme groups. We warn that while the test runs, results are not truly reliable unless the scale behaves nearly interval. If an error happens, the message is printed for awareness. Running the cell now. This output shows that the t-test ran without a technical error, but the message warns against misusing Likert scale data, which is ordinal, not interval. Although the code compared NPS scores between strongly agree and strongly disagree groups, the lesson reminds us that treating these categories as numeric intervals can lead to misleading conclusions. Always define and handle such scales carefully to ensure valid analysis. Practice. Try creating a small survey data frame with Likert or NPS-like scales and think through which statistics you can safely use. Best practices in t-test market analytics. Define your business groups, segments, before running tests. Clean and check for missing data, as it can bias results. Use effect size to explain practical impact, not just p-values. Use crosstabs for categorical comparisons, not t-tests. Respect scale types, use t-tests for intervals ratio scales only. Segment and report your findings visually for business audiences. Running the cell now. Mini end-to-end example, are customers with tech support paying more? We will use the customer satisfaction survey dataset. We compare average monthly charges for two groups, those with and without tech support. This simulates a real-world business question: does providing tech support drive higher charges or reflect higher spend customers? We clean, group, test, and interpret a result for management recommendation. Running the cell now. In real market research, group definition and data cleaning come first. We select all customers who have tech support and keep their monthly charges. We select customers without tech support and their charges. We print sample sizes for reliability, larger samples, more confidence in business decisions. Running the cell now. The output shows the sample sizes for customers with and without tech support, 2,044 and 3,473 respectively. Noticing these group sizes is important because it confirms we have enough data to compare average monthly charges meaningfully between the two groups. This step ensures our analysis will be based on robust, balanced samples before testing if tech support correlates with higher spending. With business group set, we perform the t-test to compare average charges. The t-statistic and p-value tell us if a real difference exists. We print the t-statistic. We print the p-value to assess statistical significance. If statistically significant, we provide a business call to action to review pricing or investigate value drivers. Otherwise, we recommend continuing with the current strategy. Running the cell now. The output shows a very large t-statistic and an extremely small p-value, indicating a statistically significant difference in average monthly charges between customers with and without tech support. This confirms that tech support status is associated with higher charges, supporting the business insight to consider targeted pricing or service strategies based on tech support usage. Congratulations! You have completed a data-driven business hypothesis test from start to finish. Review more analytics walkthroughs and tips on YouTube.